Greetings everyone. Today we're going to start looking at solving exponential equations. This is something we've actually already started in its basic form, but now we're going to add in expanding and condensing rules in order to help us solve. You'll definitely want to take notes on these in your own notebook. To solve an exponential equation, you first and foremost need to know your properties of exponents. Meaning, if you multiply the bases, you add their exponents. If you're dividing the bases, you subtract the exponents. If you're distributing, you multiply. All of those properties which you have in your notebook from a previous unit. You need to know how to change into log form. Remember, the base becomes the base, the exponent becomes the answer, therefore what's remaining becomes your main value. E always becomes ln, the exponent becomes the answer. Therefore, what's remaining becomes your main value. And change of base formula. In order to solve, if you get stuck with, let's say, log base 2 of 16, you need to know that you can type that into your calculator as log 16 over log 2. That should be automatic. There are two types of exponential equations that we're going to look at. The first one has exponents on both sides. The second type has an exponent on one side. There are different properties to help you with each of these. Let's explore what happens when you have exponents on both sides. Your first goal is to make sure that your bases are equal. Once your bases are equal, then it's an easy transition. Your exponents then have to be equal as well. So you actually get rid of those equal bases and set up your equation. So what if the bases are not equal? Then your first goal is to make them equal. We're going to use our exponents, and your yellow chart might be handy at this point. In this case, a common base I can make out of 9 and 27 is 3. If I have 3 squared, that's the same as 9. If I have 3 cubed, that's the same as 27. Your rules of exponents say that you distribute and multiply when you have those parentheses. Therefore, this becomes 3 to the 4x and 3 to the 3x minus 3. You need to distribute. Now my bases are equal, and I'm left with a 4x equals 3x minus 3. At this point, it's just basic algebra, and we're just getting x by itself to get negative 3. What's nice about this is you can plug your x values back in to confirm that your answer is correct. What if your exponent is only on one side? You first want to isolate the base and then most likely change it into logarithmic form. Here is my base, which means I need to isolate it, move everything else away using your algebraic rules. Instead of subtract 1, I'm going to add 1. Now that that base is isolated, I know that it's not going to be a whole number. Therefore, I need to convert into logarithm form. The base becomes the base, the exponent becomes the answer, what's remaining becomes your main value. This is why we now need to know change of base formula. Log of 7 divided by log of 2 allows me to actually plug it into my calculator. Be careful with your parentheses as always. And in this case, we get approximately, you do need to round, 2.807. Again, you can check your answer. I could type in 2 to the 2.807, subtract 1, and see if I get close to 6. Of course, it will be rounded, so just watch out for that. Let's take a look at another example. You want to isolate the base. That means I have to move the 4 over first. Right now it's being multiplied. Watch out for that multiplication. Therefore, I'm going to divide. E to the 2x equals 5/4. You can write that as a decimal if you'd like. The base is now isolated, so I can convert to logarithm form. E becomes ln. The exponent becomes the answer. What's remaining becomes your main value. I have one additional step here as x is not by itself. I'm multiplying these, so I'm going to divide both sides by 2, the whole thing by 2. So in my calculator, I need to type in ln of 5 divided by 4 and divide all of that by 2. Again, watch parentheses because you have that 5/4, or if you had your decimal, you should be okay. We are going to round our answer. We get approximately 0.1112. Again, I can check my answer. It's worth it if I know I'm going to get it right. 2 times 0.112 should equal 5. Use your E key. Use parentheses for that exponent. Times it by 4. And because we used a rounded answer, we're going to get close to 5, not exactly 5. Let's take a look at another one. Isolate the base. I need to subtract 1 first. I need to divide by 3 next. Now that the base is isolated, I can convert to logarithmic form. E becomes ln, the exponent becomes the answer, what's remaining becomes your main value. This is not an exponent, this is a main value. Now this is strictly a calculator problem. There's nothing special that I need to type in, just ln of 28, and x is approximately 3.332. Again, it's worth it. Check your answer. If I plug this into my calculator, I should get not exactly 85, but very close to 85. Take e to the exponent, times it by 3, add your 1. For next class, make sure that you have your notes that you just took on this video. We're going to work on some practice problems, and you'll also have a second video on solving. Okay, the solving needs a lot of practice, and you have to know all of those exponential, expand and condense rules already. So if you need to practice those, take the time to do so. We'll see you next time.